example 1 on maximum power transfer. Given this diagram, the question says that the circuit diagram shows a dry cell of a source 6 volts. Meaning you are given this, I explained previously that from here this is a cell, while this is internal resistance. The difference between cell and a battery, there is difference between a cell and a battery. When you have combination of cell, it becomes what? A battery. Alright, the question says that the circuit shows a source of 6 volts and internal resistance of 2.5 ohms and internal resistance of 2.5 ohms. If the load resistance varies from 0 to 5 ohms, if the load resistance varies from 0 to 5 ohms, in 0.5 ohm steps, calculate the power in each case. Plot a graph of the load resistor. Plot a graph of the load resistor on the x-axis against the power on the y-axis. Against the power on the y-axis, and state the maximum power transferred. And state the maximum power transferred. Given this circuit diagram, we are given a cell of 6 volts and we are given an internal resistance 2.5 ohms, right? And given from the question, the load resistor varies from 0 ohms to 5 ohms. 0 ohms towards 5 ohms. But in that question, we are told that the resistor varies by 0.5 ohm steps. Meaning, in this case, it varies from 0, 0.5, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, and 4, 4.5, and of course 5 ohms. From the question, we are told that the load resistor varies from 0 to 5 ohms by 0.5 steps. So this is what it means, right? So question 1 says that calculate the power in each case. That is, when R is equals to 0, calculate the power. When R is equals to 0.5, calculate the power. When R is equals to 1, calculate the power. Then up to the last value of R, which is what? 5 ohms. That was question 1. Question 2 says that plot a graph of the load resistor RL is on the x-axis, then P is on the what? Y-axis. This is your x-axis and this is your y-axis. Then lastly, step 3 says that state the value of the power of the maximum power of the maximum power transferred. Or you say dissipated. Right? From here, we've interpreted the question. This is question 1, question 2, and question 3. Question 1 says that calculate the power in each case. Number 2, plot the graph. Then lastly, state the value of the maximum power transfer. State the value of the maximum power transfer. Now, for your question 3, what's the condition for your maximum power transfer? What's the condition for your maximum power transfer? The condition is that your maximum power occurs when the value of your load resistor is equal to the value of the internal resistance of the source. Alright, say this is your source, right? Your source here is having a dry cell of 6 volts and internal resistance of 2.5 ohms, right? This is the cell of this source and this is the internal resistance. And from the theorem, it says that maximum power will occur. Maximum power of any given source will occur when the internal resistance R is equal to what? The load resistance. when the internal resistance R is equals to the load resistance. In this case, I'm giving that the internal resistance is the internal resistance is 2.5, and the load resistance, it varies from 0 to 5 ohms. It is obvious, before solving, it is obvious that in this case, I'm having maximum power transfer, or maximum power will occur when R is equals to 2.5 ohms. It is obvious because in this case I'm having the internal resistance to be 2.5, and when our load resistor is equals to 5 ohms, when load resistor is equals to 5 ohms, there is no maximum power transfer, right? When our load resistor is equals to 4 ohms, no maximum power transfer. When it is equals to 3 ohms, no maximum power transfer. But when it is equals to 2.5 ohms, there is maximum power transfer. The question is why? Following the theorem states that before you can have a maximum power transferred from a source, the internal resistance must be equal to the load resistor. So that's the concept. So before solving, this is the value of R. By the time we use this value in the formula P is equals to I square R. For the value of P, which is the power that I will be getting, this will be the maximum value of P for this source. This will be the maximum value of power for this source. Alright, let's see how it works. Figure 1 says that question 1 says that calculate the power in each case. By formula, we know that power power is equals to I square R. Call this equation 1. Let's say when R is equals to 0 ohms. In this case, I need my R. I need R, right? What's the formula for R? Mathematically, we said that mathematically, maximum power transfer I is given as E all divided by what? E all divided by the internal resistance plus what? The load resistance. Now from here, let's solve for I when we have the internal resistance equals to 0. Meaning I, implementing that formula, we have that I is equals to, so what it means is that in this case, drawing your diagram, you have 0 ohms. Meaning I is equals to your E, 6 divided by 0 plus what? 2.5, and this will give you 2.4 ampere. This will give you 2.4 ampere. 6 divided by 2.5, you have 2.4. Meaning your power from equation 1 becomes what? 2.4 all square multiplied by 0, which is equals to what? 0 watts. So when R is equal to 0 ohms, we've calculated the power transfer, which is 0 watts. Now, when R is equals to 0.5 ohms, when R is equals to 0.5 ohms, meaning in that case, your diagram, in place of 0 ohms, you have what? 0.5 ohms. 0.5 ohms. Now, using the same idea, in this case, power is equals to what? I square R. Call this equation 1. Solving for I using this formula, meaning I is equals to, what's your E? Your E is what? 6, all divided by your R, your load resistor, 0.5 plus your internal resistance 2.5 plus your load resistor 0.5. Then what do you have? 6 over 3, which is equals to what? 2 ampere. Therefore, your power is equals to what? 2, always the power of 2 multiplied by what? 0.5. This gives you what? 4 multiplied by 0.5, which is equals to what? 2 watts. When R is equals to 0, you got your power to be 0 watts. When R is equals to 0.5, you got your power to be 2 watts. When R is equals to 1 ohms, when R is equals to 1 ohms. Same idea. What's P? Your P, which is your power, is equals to what? I square R. Call this equation 1. Let's solve for our I, meaning current, using the formula above. You have that I is equals to, in this case, I have what? 1 ohms. So I have that I is equals to 6 all divided by, what's your R? Your R, meaning your internal resistance. Your internal resistance, that's what? 2.5 plus your load resistor, meaning what? 1. So this becomes 6 over 3.5. Then this gives you 1.7 ampere. 1.7 ampere approximately. Therefore, your power using equation 1, you have 1.7 square multiplied by what? R, which is what? 2.89 watts. From here, this is a tabular representation, right? Showing the load resistor, as the load resistor varies from 0 to 5. Previously, we've calculated when the load resistor is 0, 0.5, and 1, right? The same way we calculated when our load resistor was 0, 0.5, and 1. Similarly to all the value of load resistor. So this is load resistor, this is the current, and this is the power, meaning the power transferred for each load resistor. This is a tabular representation. We've tabulated our values for easier calculation. Meaning for question 1, this is the answer for question 1. Question 1 says that calculate the value of power in each cases. So when our load resistor is 0, this is my current and this is my power. When my load resistor is 0.5, this is my current, this is my power. When my load resistor is 1 ohms, this is my current, this is my load resistor. We approximated, we use 1.7 and 2.89, right? So you can go with this. So I want you to calculate each values of the load resistor and you get the corresponding value that we have on this table. So this is answer. This is number 1 answer. Then number 2, we are told to plot a graph of the load resistor on the x-axis and the power on the y-axis. Now let's say this is my graph. This is my graph representing the value of the load resistor on the x-axis and the value of the power on the y-axis. Alright, from here I'm having my power. My power is ranging from 0 to 3, and my load resistor is ranging from 0 to 5. From 0 to 5. So let's say I have this is my origin, 0, I have 1, this is 2, okay, let's say this is 1, this is 1, this is 2, 3, 4, lastly I have what? 5. This is for my load resistor. It is ranging from 0 to what? 5.0. Similarly, my power, it is ranging from 0 to 3.2. Meaning, if this is 0, let's say I have what? 1, 2. From here, let's plot our readings. When our load resistor is 0, I'm having the power to be 0. Meaning, I have it on this point. When my load resistor is 0.5, I'm having the power to be 2.0. So if this is 0 to 1, of course, 0.5 will be at the middle, and this is 2. So I have this. I have this. This is 0.5 and this is 2, right? Then, when my load resistor is 1, I'm having my power to be 2.94. When my load resistor is 1, I'm having my power to be 2.94. Alright, my load resistor, I'm having 1 here and I'm having 2.94. Meaning 2.94 varies between 2 and 3. So let's say you have 2.94 somewhere around here. Against what? 1. Against 1. So you have this. So this is, you have this. 1 against 2.94. Next up, I'm having 1.5 to 3.38. When my load resistor is 1.5, I'm having 3.38, meaning that 1.5 is in between 1 to 2, right? Let's say you have 1.5 somewhere around here, then 3.38. If this is 3, of course 1.38 will be somewhere around here, right? All right, let's say you have this is 3.38. Let's say this is 3.38 and I'm having 1.5. All right, from our previous graph sheet, once you've done plotting, picking the point of RL against P, you have this is what you are going to obtain at the end, right? Okay, from here, what this means is that, question 1 says that we should calculate the value of power in each cases. We've done that. This is the value of power. Question 2 says that plot the graph of P against RL. This is my graph. Once you are done plotting or picking the point, or you say coordinate, the coordinate of power against RL, this is how your graph is meant to be. This is what you are going to have. That's question 2. Question 3 says that state the value of what the maximum power transfer. Question 3 says that state the value of the maximum power transfer, meaning at what point, at what value of R does the maximum power occur, right? Looking at your tabular representation and your graphical representation, it is obvious that all the value of P, the greatest value of P is 3.6, meaning your maximum power transfer is 3.6, right? And it occur at what value of resistor? It occur when R is equal to 2.5 ohms, right? This is from your tabular representation. Similarly, from your graphical representation, you can see that at point, say this is A, at this point, say point A, at point A, we have the maximum value, right? Okay, let's use the idea of mathematics to explain this. When you have a curve changing from one direction to another direction, the point your curve is changing becomes what? Turning point, right? The point where your curve is changing becomes the turning point. In that case, the concept is, in mathematics, we say that at turning point, you have the maximum value at turning point, meaning maximum value occur at turning point, right? Same idea. Let's say this is your turning point. And why is this our turning point? It is our turning point because this curve is changing direction. It is changing direction, meaning at this point, comparing the value at this point to any value on this curve, meaning that this will be the greatest value among all other values compared to this curve. Alright, what I'm saying is that the maximum power occur at our turning point, which is what? A, meaning from this our graph sheet, at point A, we have the maximum power. We have the maximum value. What is the maximum value? Looking at this graph sheet, you have what? 3.6. That is, following your graph and your tabular representation, your maximum power transfer, meaning P, is equals to 3.6 watts. At what resistor do you have 3.6 watts? When R is equals to 2.5 ohms. When R is equals to 2.5 ohms. So this is the idea of this theorem, maximum power transfer. We want to know the value of resistor that will give us the maximum value of power for any given source, right? Say you have R is equals to 2.5 ohms and you have R is equals to 5 ohms, right? From here, we have R equals to 2.5 ohms and R equals to 5 ohms. We having these two values. It doesn't mean that the power of 5 ohms will be greater than the power of 2.5 ohms. No, it does not work that way, right? So that's the concept behind this theorem. And we can see that from our calculation so far. When R is equals to 5 ohm resistor, we got 3.2. When R is equals to 2.5, we got what? 3.6. When R is equals to 4 ohms, we got 3.41, right? So in essence, what we are saying is that when you have a greater value of resistor, it doesn't mean that you having a greater value of resistor, meaning your power will be maximum or your power will also be greater. No, it doesn't work that way. So that's the concept behind this what theorem. And before we start solving, we've also seen that given a question, you can easily get the maximum power transfer for that given circuit, right? Given from the question, we are given that we are given this circuit, right? We are given this circuit. So you have this circuit, the dry cell 6 volts. We are also given 2.5 ohms, and our load resistor is equals to 0 to what? 5 ohms. Without solving, without going through this process, I can easily get my maximum power transfer. Following my principle, I already know that the value of R in this case, which is 2.5, must be the value of R here. Meaning, since R, which is the load resistor, is ranging from 0 to 5, my interest should be what? 2.5 ohms. Therefore, my maximum power transfer becomes what? My current. Of course, you are going to calculate your current using this formula. You calculate your current using this formula, and we got 1.2. Implementing the formula for power, which states that I square R, meaning my I, in this case, my I is what? 1.2 square multiplied by 2.5, and this will end up giving me what? 3.6 watts. So let's say you are doing OBJ question, you can easily solve this without going through all this process. So that's how maximum power transfer works. These are first example on maximum power transfer. In the subsequent video, we will solve more questions on maximum power transfer. If you find this video helpful, do well to give it a thumbs up and share your thoughts in the comment section. Also check the description below. I'll be dropping a link to our WhatsApp group where you have access to different questions. See you in the next video.